Okay, I'm back to finish off our program. So remember we're calculating the distance the car travels while braking, and we did d equals half of the acceleration times the time squared. We also need to add the initial velocity times time. So I'm going to put parentheses around that. The initial or starting speed is here, it's 10 meters per second. And then times the time. Okay, and we enter that. That looks familiar. Okay, the final thing that we need to do is calculate the total distance the car travels. And I'm going to put that as equals, and I'm going to bold it because it's super important. Bold, and then I'm going to align it to the right. Okay, and I'm going to put it over here in my green column. That distance will be in meters. Oh, that's the wrong color, green. Let's try that again. There we go. Okay, and the distance the car travels, if I scroll up a little bit, is equal to our three distances added together. Okay, so I'm going to say equals, and then I'm going to add this distance plus this distance plus, okay, the distance the car travels while braking, plus the distance the car travels while reacting, plus the distance the car travels while distracted. Okay. All right, it's 53.35 meters. Hopefully that's what you've calculated if you're in this particular class using these particular values on your system analysis sheet. Okay, the next piece of information that will be important is the distance, the total distance to the pedestrian. Equals, okay, super important. Okay, and then I'm going to align it to the right. I'm going to bold it, and then I'm actually going to put this value in as our input. That's something that could change depending on the circumstances, and so I'm going to make it an input, and I'm going to make it purple, and then I am going to put in, I think we said the distance was 75 meters. Okay, as I was looking at all these purple columns, I noticed the starting speed of the car was not something we'd have to input, so I'm going to unpurple it. Okay, all right, and then finally, really at the heart of the issue is, how did this interaction turn out? Was the pedestrian hit, or were they okay? And so down here at the bottom, I'm going to put, even in bigger font, I'm going to make it maybe size 18. Let's see how that turns out. And then I'm going to also bold it. I'm going to say we could call it results, maybe call it how did it turn out, something along those lines. And then in this cell next to it, we're going to put an if-then statement. So this is going to be new, so we'll put equals and then capital IF, okay, and then if the distance the car travels, that is greater than, greater than or equal to the distance to the pedestrian, and what will happen? If that statement is true, if the distance the car travels is larger than or equal to the distance to the pedestrian, then we're in trouble, right? So we'll put a comma, and then if true, if the pedestrian really is in trouble, in quotes, you can put what will be displayed if the pedestrian is in trouble. So maybe something like 911, indicating there's a medical emergency if someone's hit by a car. Okay, you can choose what you say there. Okay, and then after the next column, you put what happens if that statement is false, right? If the distance the car traveled is less than the distance to the pedestrian, then the pedestrian is safe. Okay, and you can kind of choose what is said there. I'll put that in parentheses. And so when I press enter, what will I expect? I expect that the pedestrian will be safe because the car stopped before it reached the pedestrian. Okay, so safe. Now let's make this really large. Make it 18, make it bold. We can make this a special color. Maybe we can make it red. Okay, make this bold. Okay, and so that's our program.